Okay, so hello everyone. So in this video, I wanted to make a brief explanation into how you can simulate AC circuits using this software that is called Tina. Okay, so in order to simulate AC circuits, well, we can place different elements. For instance, here I will simulate the following circuit that consists of a voltage source. We have here an inductor that is in parallel with a 10 ohms resistor, and also we have here a capacitor of 1 over 20 farads. Okay, so if you want to simulate this type of circuit, you need to go here to sources in order to first place the voltage source. Okay, so this voltage source is in the AC domain. So we need to generate a voltage source that has a sinusoid behavior. So in order to simulate that, well, we click here in meeting sources, and then you go to here voltage generator, and then you double click on this element, and you select here on signal, and in signal you select here the cosine function. Okay, so you click on this element, and well, you click here in cosine function, and here you will see that you can configure the different components of the sinusoidal. For instance, we have here the amplitude that according to the problem, we have an amplitude of 20. Here, well, we need to be careful because the software is asking us to input the frequency of the circuit in hertz. But remember that the frequency of the sinusoidal is always expressed in radians over seconds. So here we have 10, but this 10 is radians over second. Okay, so we need to convert this to hertz. So in order to do that, well, we can take this value and divide this by 2 pi. And then, well, we have here the hertz. Okay, in order to convert this radians over second, we only need to divide this value by 2 pi, and we will have the units in hertz. So if you do that, you will obtain the following frequency. That is equal to 10 over 2 pi is equal to 1.59 15 hertz. No? So we need to place this in the simulator. So we have here 1.5915 hertz. Okay. So you click OK, and also you need to select here the phase angle that according to the problem, we have a phase angle of 100 degrees. Okay. So here you select the phase angle that is 100, that is the same that is right here. And here you can notice that we are placing the frequency in hertz and the amplitude of the sinusoidal that is right here. Okay, so we can, well, erase all of this and, well, we can continue. Now we have configured, well, in order to configure these parameters, you click here in OK, and then you click OK. Now we can place the other components. For instance, if you go to basic, you can select the resistor of 10 ohms. So you can connect them in this way. And well, you click here you can select in this region the value of the resistor, that in this case is 10. And you input 10 in this space and then you click OK. Okay, and you can see that the value of 10 ohms is displayed here in the resistor. And then we can place the inductor. And this inductor has a value of 0.5. So you place here the value of the inductor in this region, that in this case is 0.5 according to the diagram, and then we click OK to indicate the value of the inductor. Okay. So we will remember that this inductor is in parallel with the resistor. So you need to make this connection in parallel also in the diagram here in the software. And also we need the value of the capacitor. Okay, so the value of the capacitor, well, we click here on basic and you can place the capacitor. And this is connected in this part. Uh, okay, and the other terminal of the capacitor is connected to the negative terminal of the voltage source, that in this case is this one. Okay, so you connect all of this, and don't forget to place the reference of the circuit. That is very important in order for the software to solve the circuit. So you connect the reference. Typically, we select the reference of the circuit as the same node as the negative terminal of the voltage source. So you click here and then connect this element into this node. And well, I am forgetting to place the value of the capacitor, that is 1/20. So you cannot place fractions here. So you need to convert that fraction into a decimal value. So that is equal to, well, 1/20 is equal to 0.05 farads. Okay, so you need to ingress or insert that value into this part, and then you click OK. Okay, so basically I am placing here this value, that is the value of the capacitor into this in this section, and then you click OK. And well, according to the problem, they are asking us to find the voltage V sub 0, that is essentially the voltage of the capacitor. So in order to measure the voltage of the capacitor, we can go here to meters, and then you select here the voltage pin. Okay. This voltage pin, you can connect it to one of the terminals of the capacitor, and the voltage pin will allow us to measure the voltage between well, I am erasing this first. Well, we are measuring essentially the voltage between this node and the reference node. And this voltage V sub 0 is essentially the voltage between these 2 points, okay, or between these two nodes. Okay, so the voltage that will appear here is essentially the voltage that we need, okay, because this pin is measuring the voltage between this node, where it is connected, and the reference node. So we can erase all of this, and then we can click here. Well, according to all of this, well, I have input all the values of the inductor correctly. Okay, here the simulator define the the value of the inductor in millifarads. But these two values are equivalent, 0.5 and 500 millifarads. They are essentially the same value. Also, we have here the 10 ohms resistor, and also here we have the 5 millifarads capacitor that is equal to 1/20 farads. Okay, so now we can go here to analysis, and then you go here to calculate nodal voltages. So you click on that, and you can see that here we have the value of the voltage in the capacitor that is equal to the voltage V sub 0 in the original diagram. And you can observe here that, well, the result that we obtain, well, we have here a voltage phasor with a magnitude of 14.14 and with a phase angle of -35 degrees. And well, we can express this phasor in the time domain, or as follows. We have here V sub 0 that depends on time is equal to this magnitude of the phasor, that is equal to the amplitude of a cosine function, no, that is 14.14 times the cosine, okay, of, well, here we place the frequency of the sinusoidal, that in this case is 10 times t, and we have here the angle of this phasor, that is -35 degrees. So this is essentially the phase angle, that is -35 degrees. And well, also these are volts, okay? So essentially, This is in the simulator calculates the voltage in the frequency domain, but the problem is asking us the voltage in the time domain. That's why I'm expressing this phasor in the time domain using this expression. Now remember that to convert the phasor into the time domain, you use the magnitude of the phasor as the amplitude of the sinusoidal. You need to express the sinusoidal as a cosine function. You need to place the value of the frequency in radians over second times the time. And also you have here the angle of the phasor is the phase angle of the sinusoidal, no? That is right here. And you need to respect the sign, no? Or the negative sign of this phase angle, and that's it, no? So this is the way in which you can simulate AC circuits in TINE, no? Later I will show you how you can simulate other types of circuits. So this is like a brief introduction. So if you have a question, you can ask me, and then I will upload other videos along this week in order for you to understand better these concepts of how you can go from the diagram to the simulator and how you can verify your results in TINA. So thank you for watching. See you later.